So, hello, dear students. Good afternoon. Good afternoon to one and all. Am I visible and audible to all of you? Yeah, good afternoon, Hashira. So, can you all able to see me and hear me? Yes? Yes or no? Yes. Okay. 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 So, let's start. Okay. So, I think today we can complete this hydrocarbon lesson. Okay. In the last class, we have discussed the alkynes part, right? So we have completed alkanes, alkenes, and we are in alkynes now. And in alkynes, we have completed the introduction, nomenclature, and the preparation of alkynes, physical properties of alkenes. Okay. So now in today's class, we are moving on to the chemical properties. So before moving on to the exact chemical reactions of alkynes, we are going to deal with the acidic character of alkynes. Okay. So let us study about the acidic character of alkenes, and then we will move on to the chemical reactions of alkenes. Okay. So moving on to the acidic character of alkynes. So alkyne carbons are acidic in nature. So what is the evidence of acidic nature? The evidence is the liberation of hydrogen gas when ethine reacts with sodium metal. Okay. So I'm going to take an ethine, and this ethine is reacting with the sodium metal, and they are producing the acetylide ion, and hydrogen gas is evolved. Okay. So this hydrogen gas evolution says that the alkyne contains acidic hydrogen in it. Okay. Means acidic means the H plus is coming out from the compound. H plus is coming out from the compound. The compound which donates H plus ion, they are called as acids, right? So this indicates that. And alkynes react with sodamide also. Sodamide is also a base. So like sodium is a reducing agent, right? So likewise, sodamide is also a strong base in which it contains Na plus and NH2 minus. So that sodamide also reacts with this ethine to form the monosodium ethinide ion. So to form the monosodium ethinide with the evolution of this ammonia gas. Okay. So there is Na plus and NH2 minus here, and this NH2 minus will come and attack this hydrogen. So the electrons will move towards the carbon. So this alkyne carbon is attracting the shared pair of electrons between that carbon and hydrogen bond towards itself. Okay. So it is gaining the negative charge, and the sodium is going and forming the bond. So it is Na plus, and NH2 is coming out. Okay. So these two reactions shows that alkynes are acidic in nature. So why? What is the reason why alkynes are acidic in nature? So I'll explain you. So why they are acidic? So there is an explanation for this acidic nature of alkynes. Okay. So let us see that first. So let me take an ethine for you again. So CH triple bond CH. So we have two carbons here. So both the carbons are sp hybridized carbon. Okay. Both the carbons are sp hybridized carbon, in which the S character of the system is 50%. Okay, there is 50% S character in the sp hybridized system. So in sp3 we all know, right? sp3, what is the percentage of S character and P character? In sp3, so it is 1:3 ratio. So S character is 25% and P character is 75%. So like in case of sp2, it is 1 and 2. So it is around, S character is around 33.3 and the P character is around 66.6%. Okay. So now in case of sp, it is 1:1 ratio. So that is 50% of S character and 50% of P character. Okay. Now S character, the percentage of S character is directly proportional to the acidity. The percentage of S character is directly proportional to acidity or electronegativity, we can say. It is directly proportional to electronegativity. So the compound which has the highest S character is more electronegative in nature. More electronegative in nature. So here if you see, sp hybridized system is having the highest s character. Okay, sp hybridized system is having the highest s character. Means, so they are more electronegative carbon. sp hybridized carbon, these two carbons are more electronegative in nature. Okay, so if the system is more electronegative, so what is the meaning of electronegativity? The tendency of attracting the shared pair of electrons towards itself is called as electronegativity, right? So these shared pair of electrons between the carbon and hydrogen, they are coming towards the carbon. So hydrogen is going out as H plus by leaving its electron. So that's why alkynes are more acidic in nature. Okay, so it is more acidic in nature. Got it? So is this concept clear to all of you? If this is clear to all of you, can you let me know the answer in the chat box? If it is clear, just type yes in the chat box. Yes. Yes, okay, Aisha. So let us move on to the next slide. Okay. So now the acidic character or the acidic strength, which we are talking here, is directly proportional to the ease of donating the compound which donates more easily is more acidic in nature, right? So this point we all know. Now, all hydrogen in alkynes are not acidic. All the hydrogens in alkynes are not acidic. So only those that are attached with triply bonded carbon atom are acidic. Only the hydrogens which are attached with triply bonded carbon atoms are acidic. Very important. So let us take an alkyne again, which is ethane here. Now, these two hydrogens are attached with the triply bonded carbon. So, these two hydrogens are called acidic hydrogen. Okay. So now, when we read this compound, half mole of okay. Now, small sodium reacts with 1 more mole of sodium. Okay, and the second hydrogen is also coming out. Second hydrogen is also coming out to form the disodium ethanate compound. To form the disodium ethanate compound. Okay, so these two hydrogens, which are attached with the triply bonded carbon atoms, are acidic in nature. So now this compound we have two acidic hydrogens. So we have two acidic hydrogens in this. Okay, now I will take one more example for you. That is propane. The second example is propane. Now in this propane also we have three bonded carbon atom in which only one hydrogen is bonded with the triple bonded carbon atom. Only this hydrogen is bonded with the triple bonded carbon atom. Okay. Now these, only one acidic hydrogen we have. Now this compound on treatment with the sodium, it forms the sodium propanide. It forms the sodium propanide. Now, this sodium propanide on further treatment with sodium will not result in any of the product. Why? What is the reason for that? Because we don't have hydrogen attached to we have hydrogen, but those hydrogens attached to this carbon. These hydrogens are not called as hydrogens. So that is not for this. So when you compare ethane and propane, which one is more acidic in nature? When we compare ethane and propane, can anyone tell me which compound is more acidic? Which compound is more acidic among ethane and propane? Any idea? So in ethane we have two acidic hydrogen, right? In propane we are having only one acidic hydrogen. Which is more acidic? Which is more acidic? Unnati? Ethane is more acidic. Ethane is more acidic because it has two acidic hydrogen. Okay, good. So I hope the concept is clear. Now let us do one question. How will you differentiate between but1-ine and but2-ine? Can anyone try the answer for this? How to differentiate between but1-ine and but2-ine? So you should know to draw the structure of these two compounds first. And then only you can find out the answer. So any idea? Can you guys try? How to differentiate? If two compounds are given to you, how will you differentiate those two compounds? How can you say that this is but-1,9 and this is but-2,9? So just recall the previous reaction which we have studied under the acidic character of alkynes and try to find out the answer. Just try, just give a try. Not even a single student? Huh? Just give a try on it. Okay, let us discuss. Let us discuss. So let me take the structure of but-1,9 first. Okay. So this is but-1,9. So here this is carbon number 1, 2, 3, and 4. This is but-1,9. That is a triple bond between 1 and 2. So it is but-1,9. Now here is your but-2,9. 1, 2, 3, and 4. So this is but-2,9. So in but-1,9, we can see this particular hydrogen is attached with the triple bonded carbon. Okay. So we have one acidic hydrogen in but-1,9. But if you see the but-2,9, we don't have any hydrogens directly attached to the triple bonded carbon. So there are no acidic hydrogens in but-2,9. Okay. Now if I treat but-1,9 with sodium metal, I will end up with but-1,9 contains acidic hydrogen. Yeah, very good, Parul. Your answer is correct. So it reacts with sodium. It reacts with sodium to form this sodium butanite compound with the evolution of hydrogen gas. Okay. Now, when but-2,9 is treated with sodium metal, so there is no reaction. There is no reaction. Why there is no reaction? So no acidic hydrogens are attached to it. Okay, so that's why the reaction will not happen and no hydrogen gas is evolved out. Got it? So this is how you will differentiate. If you are getting the hydrogen gas evolving out from your container, that is your test tube or beaker, you can tell that this compound is but-1,9. If you are not getting any gas evolving out from the container, then you can come to the conclusion that this compound is but-2,9. Okay, so this is how you can differentiate by seeing the reaction mixture in the labs. Okay. So theoretically, we can find out by using the number of acidic hydrogens attached to the system. Got it? So now let us move on to one more question. So it is a statement type question. Statement 1 says that the acidic character of ethane, ethene, and ethane are in this order. Okay. Now which one is ethane here? This compound is ethane. And this compound is ethene. And this compound is ethyne. Right. Now coming to statement 2. Higher the S character in the hybridization of carbon atom, more is the acidic nature. More is the acidic nature of hydrogen atom joined to it. So, ethane, if it is ethane, the hybridization is sp3. If it is ethene, the hybridization is sp2. Okay. If it is ethyne, the hybridization is sp. Okay. Now, you have to find out the correct answer by seeing these two statements. So, 4 options are given to you. I will give you 15 to 30 seconds to solve this question. And try to give me the correct answer in the chat box. Tell me whether it is option 1, 2, 3 or 4. Option 1. Very good, Aisha. That is the correct answer. Great. Option 1 is the correct answer. Statement 1 is true. Statement 2 is true. Statement 2 is the correct explanation of statement 1. As the S character increases, acidity also increases. So that's what the statement 2 says, right? So in statement 1, you can see ethyne is more acidic in nature. And also it is sp hybridized. Okay. So both are correct and 2 is the correct explanation of statement 1. Good. So we will move on to the chemical reactions of alkynes now. Moving on to the chemical properties of alkyne, the first reaction is the addition of hydrogen. So the addition reactions which we are going to see here for alkynes, it is going to be more or less same as that of alkenes. So in alkenes, what we have done, we have we broke the pi bond present in that alkene system, and we have added the corresponding compounds, right? So in the same way, we are going to do for alkynes also. So take an alkyne, add H2 to it, add H2 to it in presence of palladium, platinum, or nickel. So use any one of these metal catalysts. You will end up with the product. So how to get the product? First, you break this bond, add one hydrogen here and another hydrogen here. So we will get this product. And this is an alkene. And to this alkene, if I add one more mole of hydrogen in presence of same metal catalyst, I have to break this bond and add the hydrogens like this in the same way to get the alkane. Okay. So let us see one example also with the same concept. It is very, very easy. So I'm taking an ethyne, I'm adding hydrogen, and I'm getting ethene. So to this ethene, add one more mole of hydrogen and get ethane. Okay. So that is about the addition of hydrogen. Very simple and easy. So we will move on to the second reaction, that is the addition of halogens. So I hope there is no doubt so far from the first reaction of it. Am I right? If you're having any doubt, just let me know in the chat box, okay? So the second reaction is addition of halogen. So take the alkene, no doubt. Okay, Aisha, thank you so much. So again, we are going to add the halogen. So what are halogens? Halogens, we represent halogens like this, right? X2. So just like how you have added the hydrogen, add the same way with this also. So take the alkyne and add halogen, break the bond, break one of the pi bond, add X and X like this, and we will end up with this dihaloalkene. Then one more mole of halogen is added. By breaking this bond, we are adding one more mole also, and we are getting the 4 halogen atom containing compound, tetrahaloalkane. Okay. If you want to see this with an example, so I have to propane here for you, and to this propane, I'm going to add bromine. So break the bond and add bromine like this. You will end up with 1, 2 dibromopropene. 1, 2, 3. Alkene should get the first preference, right? So it is 1, 2 dibromopropene. And to this propene, if I add one more mole of bromine, what I will get? Breaking this bond and adding the bromine like this, it is 1, 2, and 3. So numbering has to be given only for carbons, okay? So to carbon number 1, we have 2 bromine, and for carbon number 2, we have 2 bromine. So 1, 1, 2, 2, tetrabromopropanne. This tetrabromopropanne. Okay. So it is also easy, same way as it of hydrogen. Now coming to the third reaction, that is the addition of hydrogen halides. So what are hydrogen halides? HX. HX is hydrogen halide, right? So do you remember the Markovnikov and anti-Markovnikov, which we have seen for alkenes? The same thing we are going to apply here. So take an alkyne and add HX. Okay. Now this alkyne is symmetrical in nature. Symmetrical means if I break this compound with this triple bond, I will get 2 equal half. So this is a symmetrical compound. For symmetrical system, we don't have any problem. We can just simply break the bond and add hydrogen and X to any of the carbon, right? So if I do like that, I will get haloalkene. Now to this haloalkene, if I add one more mole of HX, what I will get? Break the bond, add H here and X here. So now you will get dihaloalkene. Dihaloalkene. So which is called as geminal dihalide. It is called as geminal. Geminal is written like this, gem dihalide. If 2 halogens are attached to the same carbon, then that compound is called as geminal halide. If 2 halogens are attached to the same carbon, it is called as geminal halide. If 2 halogens are attached to the adjacent carbon, then it is called as vicinal halide. We have discussed about this vicinal in the previous alkenes and alkanes, right? Now geminal is here. Got it? So this is the difference between geminal and vicinal dihalides. Now let us see an example for this addition of hydrogen halide. So I am taking ethyne first. So to this ethyne, add HBr. So break the bond. This ethane is symmetrical, so we can add it in either of the ways, and we will end up with this bromoethene. So here we have added the other way around. So here bromine is added. Here bromine is added. Okay, and here hydrogen is added, and we have got this bromoethene product. Now to this product, you add 1 more mole of HPr. Just break the bond. And here we have to use Markovnikov addition, right? So to this alkene carbon, we have 2 hydrogen. And here we have only 1 hydrogen. So the addition molecule, that is H plus and Br minus. So the hydrogen of the addition molecule goes to the carbon which has more number of hydrogen. That is Markovnikov addition, right? So this carbon only has 2 hydrogen, which is more in number. So hydrogen has to go here and bromine has to go to this carbon. And we will get this product. And it is called as, it is 1 and 2, 1, 1 dibromoethane. 1, 1 dibromoethane. Okay. So any doubt? So here you can add, and here you have to use the Markovnikov addition. That's it. So just keep the Markovnikov part alone here. The rest all are same. Shall we move on to the 4th addition? That is the addition of water. Shall we go to the addition of water? Is everything clear? Yes. Okay. So moving on to, yes. Okay. Oh, okay, Harshita. Yes. Addition of water. So let us take an example. Ethane. And we are going to add the water, H2O. Now here we have to use some catalyst. And that catalyst is a mercuric sulfate. Mercuric sulfate. So from that mercuric sulfate, mercury ion is interacting here. And it is the metal. And in presence of acid, that is H plus. And you have to heat this mixture to 333 Kelvin. Okay. Now what we have to do? We are going to add the water, right? So water contains H plus and OH minus. So break the bond, add H and OH. You will get the product. Now this is called as ethanol. Why it is called as ethanol? We have an alkene and also an alcohol. OH containing compounds are called as alcohols, right? So since this compound contains both alkene and alcohol, it is called as ethanol. Okay. Now this ethanol compound undergoes tautomerism. This compound undergoes tautomerism to give the ethanol. To give the ethanol. So what is al? Al means aldehyde. So how we are getting this? How we are getting this? Or these 2 compounds are interchangeable. This is undergoing tautomerism. So both are having the same molecular formula but different arrangement of atoms. So they are one of the isomer. So how we are getting this means you have to shift this hydrogen which is attached to oxygen to this carbon. And you have to shift the bond here. You will get this aldehyde. Okay. So take the, I'll show you. So what you do, take this hydrogen which is with this oxygen and put it to the alkene carbon and shift the double bond here. Okay, you will end up with this product, CH3CH2, ethanol. Is this clear? I'll show you with one more example also. I'll take propane. If I want to add water to this propane, what I have to do? How to get the propane? So for propane, we have to follow Markovnikov addition, right? Because propane is not symmetrical. Yeah, clear. Okay, Hashira. So it is unsymmetrical system. So here you have to do Markovnikov. So break the bond, and this is H plus and OH minus. H has to go to the carbon which has more number of hydrogen. Now if this is carbon 1 and this is carbon 2, carbon 1 has 1 hydrogen, carbon 2 has 0 hydrogen. So the hydrogen of the adding molecule have to go to the carbon, triple bonded carbon, which has more number of hydrogen. So it has to go here, and the negative part has to go to the carbon which has less number of hydrogen. Okay. So this is how we are adding and getting the product. Now here it is prop 1E to all. 1, 2, 3, right? So 3 carbon containing system. So it is prop Between 1 and 2, we have a double bond. So 1 ene. And in the second carbon, we have the alcohol. So it is prop 1 ene and 2 all. Okay. Now this compound, this enol undergoes tautomerism. This enol also undergoes tautomerism. So what we have to do? How we have to do the tautomerism? So take the hydrogen from oxygen and put it to the alkene carbon and shift the bond here. Okay. So what you will get? CH3, C double bond O, CH3, which is called as propanone. It is called as propanone. Okay. So this is how you have to tautomerize. So tautomerism is one of the type of isomerism under structural isomerism. Okay. Tautomerism. Like we have chain isomer, functional isomer, positional isomer, no? So tautomerism is one of the structural isomerism in which the molecular formula will be same, but the functional group will be differing for them, tautomers. Okay, so one will be the enol and the other one will be the aldehyde or ketone. Okay, for if you are taking ethyne, you will end up with aldehyde. If you are taking some other alkyne other than this ethyne, you will end up with ketone. So only for ethyne you will get aldehyde. For rest of the alkynes you will get ketone. Okay. So one of the compound will be the ketone part and another one will be the enol part. So this tautomerism is called as keto-enol tautomerism. So some other tautomerisms are also there, but for our syllabus we have only keto-enol tautomerism. Okay. So fine. We will go with the fifth reaction, that is the polymerization reaction of alkynes. Polymerization. So how do we get a polymer? By repeating the monomeric units, right? So we have two different types of polymerization here. One is the linear polymerization and the other one is the cyclic polymerization. So that cyclic I will discuss next. Now we will study about the linear polymerization. Now what is linear polymerization? Under suitable conditions, linear polymerization of ethyne takes place to produce the polyethylene. So you remember polythene polymer we have prepared in alkenes, right? So the same way we are going to prepare polyethylene, which is also a polymer. Okay. So let me take ethyne. I have took n moles of ethyne. So how to get the polymer? We have to shift the bond. Just shift this bond here and one electron here, and from this also you shift one here and shift another out. So we will get a new carbon-carbon bond between these two carbons, and here we will have double bond, and here also we will have a double bond, and outside this we will have single bonds. So we will end up with this type of product, and this is the polyethylene. This is polyethylene. Okay. So here this polymer, it is formed in the linear fashion. So we don't have any branches here. So that's why this is called that's linear polymerization. Got it? Now coming to the cyclic polymerization, for that we have to take 3 moles of alkyne. So here 3 moles of ethyne I have took. Okay. Now this ethyne is put into the iron tube. It's put into the red hot iron tube. And it is heated up to 873 Kelvin, which is a very, very high temperature. Okay. At this very high temperature, one of the pi bond from the alkyne will come and form the new bond with the carbon-carbon. Okay. And this bond also shifts there and that bond also comes here and they will produce the benzene. They are producing the benzene. So these are the 6 carbons. And these are the newly formed bonds. So which is an aromatic compound. Okay. So we are getting aromatic compound from the system. Now I'll ask you one question. Instead of this ethyne, if I use propyne, what will I get? Instead of ethyne, if we take propyne, what will we get? We will not get benzene for sure, right? So we will get some other product only. So what is the name of that product? Can anyone guess? Propyne, if I take propyne. Propyne means I have to replace this hydrogen by methyl group, right? I have to replace one of the hydrogen by methyl group. So what will I get if I take propyne? So this is propyne, 3 moles of propyne. So I'll get the same ring, but there will be a substitution, right? There will be a methyl substitution here. So what am I getting? 1, 3, 5 trimethyl benzene we are getting. So this is how you have to do the cyclic polymerization and get the product. Got it? So I hope this is clear to all of you guys. So this is the last reaction of chemical reaction of alkynes. So now let me summarize the alkynes part. Okay. So the general formula is CnH2n minus 2. And for nomenclature, we have to use YNE. And we have seen 2 preparation. One is from calcium carbide. Okay, one is from calcium carbide and the other one is from vicinal dihalide. And in vicinal dihalide, we had used the beta elimination reaction using alcoholic KOH and sodamide. Right. So these 2 preparations we have seen. Both are very, very important. And coming to the physical properties, they are colorless, odorless, and they will not get dissolved in water. Right. So they are dissolved only in some organic solvents. And coming to the chemical properties, they are acidic in nature. Why they are acidic in nature? Because the electronegativity of the triple bonded carbon is more. Okay, that's why they are acidic in nature. And they react with sodamide to form this ammonia and this sodium ethanide also. And next we have seen the addition of H2. Addition of H2 leads to the formation of alkane, right? And addition of halogen leads to the formation of tetrahaloalkane. And addition of HX leads to the formation of here, it should be single bond, okay? It is not double bond, it is a single bond. And addition of HX. So if symmetrical, system is symmetrical, then add the molecule. While coming to unsymmetrical system, do Marconi curve. Okay, the first step would be the general thing and the second step would be the Marconi curve addition part. Okay, in this addition of HX. Then in addition of H2 also, we have used the same Marconi curve addition for unsymmetrical and for symmetrical, the same thing. And here tautomerization concept came into existence. And you should know how to form the tautomer. Okay, how to prepare the tautomer. So just revise that part. This is about the addition of H2 and coming to the last reaction, that is polymerization. There are 2 types, linear and cyclic. So cyclic polymerization leads to the formation of a more stable aromatic compound. So this is what we have discussed in alkynes. Okay, yeah. Cyclic polymerization leads to the formation of aromatic compound. Yes, Shamila, cyclic. Good. Now, we are going to see the last topic, but a very important topic of this lesson and for a whole organic chemistry. Okay, that is aromatic hydrocarbons. Aromatic hydrocarbons. So here, the learning objectives under this topic are the introduction, structure of benzene. So mostly we will discuss about the benzene only here. Okay, because we are dealing with only the hydrocarbon. So the very easy and very simple and very common aromatic hydrogen and carbon containing compound is benzene. So throughout this lesson, we will study about the benzene only, preparation of benzene, preparation of, chemical reactions of benzene. Everything is with benzene. Okay. So we will do that. And the resonance and stability of benzene, preparation, chemical property, physical property, etc. Got it? So let us try to complete this. Yeah. We will move on to the first topic, that is introduction. Introduction. So what is the introduction of aromatic compound? So these are also called as arenes. Yes, Suhana, yes. So aromatic compounds, hydrocarbons are also called as arenes. Why they are called as arenes? Most of the arenes possess pleasant odor. They possess pleasant odor. Aromatic compounds possess pleasant odors, a sweet smell, a pleasant smell. Okay. So aroma means pleasant smelling. Aroma means pleasant smelling. That's why we are calling these compounds as aromatic compounds. So if you are smelling the benzene, it will give some pleasant smell. Okay. So mostly chemicals, they will not give the pleasant smell, right? So they will be some kind of a dizziness kind of smell only they will produce. But aromatic hydrocarbons, they have the pleasant smell. And most arenes were found to contain the highly unsaturated benzene ring. So what is meant by unsaturation? The double bond and triple bond containing system. Okay. So most of the aromatic compounds contains this benzene ring, and those compounds are called as aromatic compounds. Aromatic compounds are divided into two. One is benzenoid compound and the other one is non-benzenoid compound. Okay, non-benzenoid but aromatic. So what is the difference between benzenoid and non-benzenoid, students? Both are aromatic only. But why they are called as benzenoid and non-benzenoid? If the compound contains the six-membered benzene ring in it, then it is called as benzenoid. So this is benzenoid. And if a compound contains seven-membered ring, so now this is seven-membered, right? So double bond here, double bond, and there is a double bond. Okay, let me take this propone compound. Now this is 1, 2, 3, 4, 5, 6, 7. So this ring contains 7 carbon. But this compound is aromatic in nature. So that's why it is coming under the non-benzenoid compound. Okay, so let us study about these things that have at least, yeah. Okay, yeah, good. Benzene is 6, yeah. Yeah, this is naphthalene. This is naphthalene, which contains 2 benzene rings. Benzene contains only one. Okay, one ring. Okay, so which contains 6 carbon in it. Okay, so if 2 benzene rings are fused together, they will produce an naphthalene. But both rings contain 6 member ring only, right? So here also it is a 6 member ring, and here also 1, 2, 3, 4, 5, 6. 6 carbon only made this ring also. So these two are 6-membered rings and this is a 7-membered. So that's why this is benzene and this is non-benzene. Is this clear for all? This is clear for all? Yes. Okay. So I'll show you some examples also. First, very important example is benzene. And if I am substituting a group like methyl, NH3, like if I am substituting any group to this benzene, then also it is called as benzene compound. It is also an example for aromatic compound. Now, if I substitute methyl group, it is called as toluene. Now, these two rings you see, but 2 C is common for both. Both carbons are common. Both the carbons are common for both. Both the carbons are common for both. But still, we have to take that. Okay, this is called as naphthalene. Okay, so it is these two carbons are common for both the rings, but we have to take that carbon for both. We have to consider that carbon because without that those two carbon, this ring would have not formed, right? They are just fused together. Okay, we have to consider that. This is one 6-membered and this is another 6-membered. I didn't tell that the ring is the 6 carbon containing. I told that it is a 6-membered ring. Okay. So here in this biphenyl you see, yes, in this biphenyl you see 1, 2, 3, 4, 5, 6. Now these two are the separate ring. And here 1, 2, 3, 4, 5, 6. Okay. 6 carbon. Still they are aromatic, but the name is different, you see. The name is not naphthalene, it is biphenyl. Okay. Because the total number of carbon here, it would be 6, 7, 8, 9, 10 only. Here we'll have only 10 carbon. But here we are having 12 carbon, right? So the compound itself is different. That is biphenyl and this is naphthalene. Both are aromatic. So 2 6-membered ring we are having there. 2 separate 6-membered ring we are having. And here the 2 6-membered rings are fused together. Got it? So I hope this is clear to all of you. So this is about the introduction of aromatic hydrocarbon. Now let us move on to the structure of benzene. So already you might have aware of this, right? Previous slide you want, Aisha? Which slide you want, my dear? This slide or this slide? You want me to show this slide? First slide. This one. Okay, okay. Take a note of it first. Are you all taking the notes in your notebook, or you guys are taking the screenshot of it from the mobile or laptop? May I know? Notebook. You guys are writing. Okay, okay. Am I going very fast? Do you guys want me to? Oh, all of you are taking in your notebook. No, no? Okay, taking notes in notebook. Okay, okay. So if I'm going very fast, just tell me. Okay? Don't hesitate to tell me. If I'm going very fast, just tell me. And it is slow. Okay. So everything is clear. In the upcoming classes, if you find any difficulties, yeah, sure. Okay, okay. Thank you so much, student. Shall we move on to the next slide? I think Aisha have asked for this link. Aisha, have you completed? Yes. So examples also, you just note it down. Yes, Lakshmikant, you have raised your hand, it seems. You have any doubt? If you're having any doubt, just tell me. No doubt? Okay, I think he have raised his hand by mistake. No issues. We will move on to the structure of benzene. So this is the structure. So there is 6 carbon and 6 hydrogen attached to the carbon. Okay. So we have 3 double bond in it, and all the 12 atoms, 6 carbon and 6 hydrogen, they are present. They are in the same plane. They are in the same plane. Okay. Because the hybridization of all the carbon is sp2. The hybridization, all the carbons you see, all are having the double bond. All the carbons are having the double bond. So all are sp2 hybridized. So what is the geometry for sp2 hybridized system? It is trigonal planar. It is trigonal planar, right? So everything is there in the same plane, xy plane. Got it? So this is the structure of benzene ring. You all would be knowing. And if the carbon is sp2, the geometry is trigonal planar, and there are 3 sigma bonds around each carbon and 1 pi bond around each carbon. Okay, there will be 3 sigma bond and 1 pi bond around each carbon. Okay, 2 sigma bond is between carbon and carbon, and 1 sigma bond is between carbon and hydrogen. So this is that. Okay, so let me show you the orbital containing system diagram also. So this is the orbital representation. So we have 6 carbon, and here carbon, carbon, sigma bonds we have. How many carbon, carbon, sigma bonds we have? 1, 2, 3, 4, 5, 6. Very good. Yes. 6 carbon, carbon, sigma bond we have. And there is 1 p orbital. Very good students. Very good. It is 6. So, and we have 1 unhybridized p orbital for each carbon. And there is 1 electron present in all those unhybridized p orbital. So now all the carbon atoms are in a single plane. P orbitals are aligned. They are aligned in a perpendicular manner. Okay, to that plane. This is the plane. All the p orbitals are perpendicular to each other, and each p orbital is overlapping in a sideways manner to form that pi bond. Okay, so this is 1 pi bond, and this is the second pi bond, and this is the third pi bond. So we have 6 carbon, carbon, sigma bond, and 3 carbon, carbon, pi bond. Now these pi electrons, they are delocalized. They are delocalized. So here in the structure you see, they are overlapping between carbon 1 and 2, and here between 3 and 4, and here between 5 and 6. Now in the structure you see, it is between 2, 3, 4, 5 and 6, 1. So they are resonating. They are resonating. So since resonance is possible, what is meant by resonance? Resonance is delocalization of electrons, right? So if the electron is getting delocalized in the compound, then that delocalization brings the stability to the compound. If a compound contains more number of resonance structure, then we can say that the compound is more stable in nature. Okay, so the delocalization of electrons brings the stability in benzene. So there are two resonance structure possible for benzene. One is the previous structure which I have shown you, and this is the second structure. We have two resonance structure. It brings the stability. So is this clear? This is very easy, and you might have already studied this. I've already taught this in GOC lesson also, right? So the same thing is here. Shall we move on with the preparation of benzene? Are you all ready? Yes. Okay. So there are three preparation. We have three preparation. So first of all, benzene is commercially isolated from coal tar. You all know the tar, right? So the carbon containing compound. So it is commercially isolated from the coal tar, and the laboratory preparation, laboratory method, and this is the industrial preparation. And in the laboratory, if we have to prepare benzene in very small amount, then we have to do that. We can do that by three methods. First is by cyclic polymerization of ethane, which we have studied now. Now in the reactions of alkanes, we have discussed this, no? The same reaction. The ethane with red hot iron tube, it produces benzene, the same reaction. Okay. The first method of preparing benzene, okay, is from the ethane. Is from an aliphatic compound, ethane. Then the second preparation is from decarboxylation of aromatic acid. Decarboxylation. So this, the same type of reaction we have studied in alkanes preparation. There we have took the aliphatic salt of carboxylic acid, and here I am taking the aromatic salt of carboxylic acid. Okay. Now if I attach COOH to this benzene, if I attach COOH to this benzene, this compound is called as benzoic acid. Now if I want to make the salt from this benzoic acid, I will have to treat this with another compound, and I will get COO minus and Na plus. So this is the sodium salt of benzoic acid. Sodium salt of benzoic acid. This salt is treated with NaOH and CaO. Do you guys remember the name of this reagent? Let me see who is telling this. What is this? What is the name of this mixture? Sodium oxide and calcium oxide. Sodium hydroxide calcium oxide mixture is called as none of you remember? So you guys are not studying or what? Hmm? None of you could recall the name of this mixture. It is soda lime. Yeah, very harsh. Soda lime. Just turn into your alkanes preparation. You will find this. Very good. It is soda lime. Soda lime mixture. So what will happen if we treat the compound with soda lime? Na2CO3 will come out, right? Na2CO3. Na2CO3 will come out, and this hydrogen will go and form the bond with this carbon. We will get C6H6. And then C6H6 CO3 is gone up. Okay. So this is the carboxylation preparation. Now the third is the reduction of phenol. Third method is the reduction of phenol. So what is phenol? Which attached to the benzene ring. This one is phenol. Okay, C6H5, which is called as phenol. And what you have to do? You have to reduce this phenol. For this reduction purpose, we have had reducing agent, right? So mostly else will act as a reducing agent. So here in this reaction, we are going to zinc metal. Zinc metal used here and heated up. And here, if you see, what is reduction? removal of oxygen. So what you do, remove the oxygen, Z and O is removed, and we are getting C6H6. Okay. So by reduction of phenol, you are getting the benzene. So these are the very important three main preparations for benzene. Okay. Now it's already 3:57, right? So tomorrow we can discuss. Tomorrow we can. Yeah, Deepak. Yes, tell me. You have raised your hand, it seems. Okay. Tomorrow we can discuss the chemical properties of benzene. So we can complete. I think we are not able to complete this lesson today. Tomorrow for sure we can complete this lesson and we can move on to the next lesson. That is P block. Okay. So we will move on to the P block lesson tomorrow. P block lesson is not included for you in your board exam. So it is very new to you. So try to join the class. We will complete this lesson and we will start a new lesson tomorrow. Okay. So today what we have discussed? We have discussed the chemical properties of alkynes and all the introduction, the preparations of benzenes. Okay. Tomorrow we will go to properties. If you're having any doubt, you can raise your hand or you can ask me. Yeah. If you're not having any doubt, then we can meet tomorrow. Thank you all so much for listening the today's lecture. Okay. Okay, no doubt, no doubt. Thank you, Hajran. Thank you, dear students. Thank you all. Bye-bye. Yeah. Thank you, dear. Thank you. Thank you, Aisha.